All right, we're gonna get started. Yeah.
Recorded, right?
I need to start recording it.
Okay.
I'm actually technical.
Expert.
All right. Can I get people's attention, please? Due tonight is your first peer review, so I revealed it this morning. I feel a little bad about making it due tonight. This is just so that I can get that feedback to people turned around, preferably tomorrow morning. If you don't get it in tonight for the very first time, I will accept it late. I would much rather have you submit it late than not submit it. And that's just, I don't like assigning something the day that it's due, but I would also like to make sure that you leave enough feedback here that is useful to people. So let me just walk you through exactly what's here, what you should be putting, and what I am looking for, how I will use it, what I will do with it. So this is something that you will fill out 10 times this quarter. That's a lot of times, but it's also useful and relevant to kind of take the temperature of your group, figure out how things are going, be able to provide feedback with you for you so that you can make the associated changes before it affects your grade. Because remember that your grade is scaled by how your group is perceiving your effort and technical contributions within this group. So you need to be vocal, you need to be there, you need to be doing the best to create the best team environment that you can, while also doing the best technical contributions that you are capable of, given your background and the requirements of what you take on in each sprint. So the first one is for grading yourself. So your name, you're going to grade your own effort and technical contribution. And you will provide comments for both your effort. How have you been showing the effort that you have been putting forth? As well as what did you contribute technically? If there are issues here about it, you can also explain and have some comments about, I didn't feel like they did as much this week as everybody else, something of the sort. So this isn't just a list of what was contributed. You can also add some of your thoughts and comments on this. So note that the 1 through 10 here, you need to mark either with an X or a number or something somewhere in this row and somewhere in this row. So 2 grade items per person. Then you're going to go through each other member of your team who is not you. And you're going to do the same thing for them, and the next person, and the next person, and the next person, and developer 5 will only be necessary if you have a 6-person team. So this may just be not applicable if you have 5 people on your team. Be as verbose as you want in these sections. And the reason is that on a weekly basis, Hunter or I or both of us are going to be looking through these comments, looking for potential problems. And if that is the case, then we will be notifying you basically of that problem the week that it happens via some private Discord message or private email. Those are the 2 things that you could be looking for if we believe that the rest of your team feels like you're not pulling your weight or something of the sort. I do reserve the right to pull these comments directly from what you type or write. I will strip the name. So they will not know that it's coming from you. But because of that, please make sure that your comments, everything here is something that is constructive. Make sure that you feel like you are talking to that person to help them to do the best that they can moving forward. You don't want to create an unhealthy team setting. This is not a place necessarily for you to just vent. If you need to vent, that is okay, but make sure that it's done in a constructive way, so that if this were sent to that person, they would have some avenue. What can they do about it? How can they move forward? How can they improve what they've been doing to better interface with your expectations for their contributions to the team? Does that make sense? That's kind of what I'm looking for here. So your grade will be scaled by some formula applied to this. And I never know on a class by class basis how friendly we all are to each other, how much we all hate each other. So I'm not gonna specify exactly what that formula is. I use that as part of the class scaling. If you all just end up hating each other, I'm not just going to fail all of you because of what's some predetermined formula that makes everybody's grade an F. So I want it to make sense, scale well, and give people the grades that they deserve based on the feedback that they're getting. So that's why I will not make the formula public. I don't even necessarily know what it's gonna be quite yet, but it will be based on these scores, and remember that there are 10 of them. So if you receive some of that negative feedback to begin with, then make sure that you are addressing it, you're taking it seriously, and you're making the changes that are suggested there so that you can better interface with your team. Other questions or comments about the requirements? These will be every Tuesday night that we have a sprint active. So that's gonna be just about all of them except maybe something like Thanksgiving, the week after Thanksgiving. We don't need a peer review for the effort and technical contribution of how much you contributed to your Thanksgiving dinner and the effort you applied, your body applied when dealing with all of the food you ate over Thanksgiving. Should not be public information. All right. Questions about anything else about the project or where we are going? So tomorrow we're gonna have a lab period. That's gonna be 2 hours of just work time. People can be productive. Now that you're getting feedback on your user stories, I would start thinking about what are the scenarios? What are the tasks? Get those tasks into your issue tracker in GitHub and start making progress. Today's lecture is going to cover a very brief introduction to UML. I have a whole slide deck that I'm going to be going over very quickly and hitting just kind of the important points and slides because a number of people in here have seen this deck before from design patterns. That's not a reason why we shouldn't go over it in that level of detail, but we just don't really need that level of detail to be able to produce what we need to produce. The more important thing for later is I want to start talking about code reviews because I'm going to be expecting that the contributions that people make are code reviewed. So I want to go over exactly what that format looks like so that you can start doing that in a way that helps make Sprint 1 easier. So that's what we're going to do. I have not edited this slide deck at all, so you can see that it still says 212 on it. All right, so I don't care too much about some of this intro, not as relevant to what we're doing. What's important is what UML is, Unified Modeling Language. I can kind of talk about why we use it in computer science. It's because this becomes a visual way of communicating between different kinds of developers and designers and clients. We interface with a bunch of different people in our field. And so being able to actually have a diagram that is that communication, it's visual, it is often non-technical. Or if it is technical, it's technical in exactly the ways that can be used to communicate with that subset of people for whom that diagram is meant to communicate. But because of this, we have a bunch of different kinds of diagrams. We're only going to focus on a couple of them for the sake of this class, because that's really what we're designing for. So there are a bunch of different modeling languages, and UML is really just putting them all kind of in a bin and using them all as we need them to describe certain aspects of our code. So yes, we're going to talk about some of these. The most important here are going to be class diagrams because that's what we are making a UML editor for, is for class diagrams. And the class diagrams will, and I guess object diagrams as well. Some of both of these for structural models, because structural models are what we are used to working with ourselves. But there are plenty of other diagrams that you can go research, or I will quickly go over depending on how long this takes. So a use case diagram is useful for something like, let's actually look at something that could be considered to be a use case diagram. So here we have our users, We have a waiter, a client, a cashier, and a chef. We have associated lines between how they interact with what might be considered different actions. So a waiter is responsible for receiving the order when the order food action happens. The client places the order, the waiter receives the order. So you can see that it just by analyzing this diagram, you get a sense of how a restaurant might operate, the expectations, the roles. If you were to write code to simulate a restaurant, what aspects of code would represent which aspects of this diagram? What is what?
What would be like the classes?
So, yeah, maybe the methods associated with things, but you can see that this isn't quite an object-oriented type of diagram, right? Like there are classes, but they're more so the cashier is a class that interfaces with these in some capacity. But you can see that some of these methods affect different classes in different ways. So the client is the one that initiates the order food, but it needs to be sent to the waiter so that the waiter can facilitate, taking it and giving it to the chef to confirm the order. So there are different actors are acting with each other in different ways. So this isn't an object-oriented diagram, but it could be converted to be one if that was the way that we wanted to implement this. So, project and resource management system. Here is a very high-level system. These diagrams don't have to be complicated. You can assume that managed resources is itself a significantly more complicated subsystem. But you can abstract that subsystem into just a name or a title, and that helps us to be able to do a high-level abstract visualization of what's going on. So if you wanted to, as part of your design, try to figure out, all right, what are the requirements of sprint 1? Can we visualize that as a diagram? We need to be able to have certain levels of functionality. We need to be able to write certain amounts of code. So even before diving in and writing the code, you can go into a design phase where you're drawing diagrams like this that says who's responsible for what within the project. These are not developers. This is a high-level view of a system. But if we wanted to go into the managed projects, we're going to kind of blow this up, and that'll be its own separate diagram. So that would look something like this. This is that box or that circle from the prior slide, where now we can understand, okay, managing projects, what does that entail? We don't want all of this to be in the prior diagram, it gets too busy. But having multiple diagrams at different levels of abstraction can help us to understand the system when you're doing the system architecture design. That's when you want to have the most abstract diagram in front of you. When you're dealing with the actual implementing of code, you probably want to be looking at the lower level, but you could even hand out different diagrams to different people to say, you're responsible for this infrastructure, you're responsible for this other infrastructure. They're going to combine in ways that look more like this. This is our whole project, but we now want to be able to divide up the work so that it makes sense. So you can use UML as a way to plan your projects. So this is also use cases. Who's responsible for what in a system? So that's how you should think of use case diagrams. How is this system being used? By whom? Who is interacting with what? So it's kind of a process description. Class diagrams we'll spend a lot more time on because this is what you're going to be making in this class as a UML editor for class diagrams. So when the user wants to add a class, they type in the name of a class. That's what's going to go in something like this aspect of a box. Right now, you're just using a command line, but you can kind of imagine this as one big structure, the structure that represents the class. Classes, of course, have fields and they have methods. Some of those methods have parameters. So this gives us an object-oriented view of an actual class and the breakdown of a class. What are the components of the class? What is the functionality? What is the behavior of the class? Questions so far? Yeah.
For our command line, when we're just printing out what classes have what, can it literally just be like bolded name class, like indented list methods?
Sure.
Okay.
Yeah,
So-
however you think that structure makes sense, think about it from a client's perspective. Is this usable? That's all we really care about. Does it, one, do the task? Like, does it list everything associated with the class? So all of the fields should be, let's say, the name of the class should be listed, the fields should be listed, the methods should be listed, and any parameters for those methods should be listed. How you do that is completely up to you. It's kind of a checkbox binary. Did you do it or did you not? Which is a different question from, is it understandable? Is it usable? Is it visually appealing? Those are all abstract questions that may vary on a person by person basis. And if you're trying to write a program that's usable to a vast majority of the people out there, you can't just design an application for yourself. You can't just design an application for Tony, your client. Maybe that's one of many clients. You want to mass produce this. You want to be able to sell it in the future. You want people to think this is the ultimate UML editor. Why would anyone ever make another one of these? Everyone for the rest of the history of the universe will use mine. That would be the ideal case. That will never happen. But it would be great if that could be, because that's what you want to be thinking about as you're designing it.
It's gonna be like, Tony's gonna be like, all right, I'll give this program a try. He's gonna type and his head's gonna like blow up and confetti's gonna fly out.
Exactly. And then you'll wake up.
Yeah. And then I'll like be on the floor because Tony punched me because my program was so bad. I feel like I could achieve that.
So I want to talk about relationships because right now we just have generic relationships between things, but I will spoil this for Sprint 2. Relationships will have types eventually. So it is worth knowing what those types of relationships are between classes so that you can have that level of functionality. Right now, binary, two classes are either related or not related. So many different relationship types. We can have association, and association itself can be directed or undirected. We can have reflexive association, multiplicity, aggregation, composition, generalization, realization. This is mostly what we care about, and you'll be implementing only a subset of these for this project. I'll leave the rest of them to just kind of be on your own. You can add them if you want to. You don't have to if you want to eventually show this off to a prospective employer. Maybe it's worth doing. So association, I like starting with it because it's the default. If the relationship isn't another type that is in this list that we're going to talk about, it is the default. It's the else case for the long if, else if block that's about to follow. It's the bin that collects all remaining relationships at the bottom. Two classes that are somehow broadly related, but not in any way that we're going to be talking about with regards to the other types. So an example of this, I use the 212 examples from the airplane project that I invented for that class. But the example that I use is an airplane passenger and an airline. Not the airplane, not the airport, but the airline that owns the airplane that you're flying. That's a really strange relationship, wouldn't you agree? Like, they are related. I am flying on a flight being operated by this particular airline. So there is a relationship there, but it's not a very specific relationship. So this is just going to be thought of as if we have two class boxes, note that these can expand to include all of the fields, all the methods, everything else that you might want. Visually, we just have a line between them. Again, it's just the default. These are related, but I can't really specify how. in more detail. Note that this isn't really a directed association either. There's no real ownership. The airline doesn't own the passenger doesn't own the airline. There's no one way to the other way. It's just, yeah, there's this relationship. But it exists. A directed association is just like this, except that there's some kind of directionality to the relationship. So an airplane to its passengers now has a direction. You're a passenger on an airplane. So airplane to passenger, or sorry, passenger to airplane might make more sense. So you want to go from the container to the containees. So from the airplane to the passenger. The airplane is the container surrounding the passengers. It's a really weird way of thinking about flying, but here we are. So this is again just that arrow, but now we're going to have an actual directed arrow at the end of it that shows there's directionality to this association. We go from here to here, container, containees. Reflexive association. When you might have multiple possible functions, responsibilities between things, you can have a reflexive association. So a staff member, which is kind of a generic way of saying it could be a pilot, an aviation engineer, a ticket dispatcher, a guard, a maintenance crew member, someone who is a staff member may have a relation with some other staff member. So for instance, we might have an aviation engineer that is responsible for a particular something. Maybe a maintenance crew member and a pilot are connected to the same plane. So aviation engineer oversees the maintenance crew member, something of the sort. We can also have numbers associated with these relationships. So this says, kind of as input, we have 0 or more airline staff associated with 0 or more airline staff. Kind of, we don't know, but there could be some relation between some of the more specific versions of the airline staff and each other, but not in a way that we are prepared to specify right now. So this would be a perfectly fine class diagram or class piece, class and relationship to, you have a relationship with yourself if you're a class. So do note that as a source and a destination, that is possible for a relationship to have source and destination be itself. We call that reflexive association. Multiplicity tells us the cardinality of one class to another, how many of one. So something like an airplane and its passengers. We know that an airplane has multiple passengers, so there can be a multiplicity relationship. We already talked about this exact example as a directed association. So there can be multiple different relationship types, especially for how this system might be designed. Right now, we're only accepting one relationship type, but multiplicity helps us to also know that an airplane doesn't need passengers to operate. You can fly an airplane with no passengers. I'm putting a distinction here between the pilot and passengers, because you either need a pilot or a really good AI to fly a plane. So since we have an abstract airplane class, we don't know the size of the airplane. We don't know how many people there could be on the airplane. So we don't really have an upper bound that we can place. So again, we use this number to say that this is attached to the passengers. So one airplane has 0 or more passengers, and whichever side this is closer to tells you that. One of these has 0 or more of those. Since this is closer to that, that's the directionality of it. You could add that it's a directed association as well as a multiplicity if you added the arrow, which we really should have here. Really important distinction between aggregation and composition. So both of these are associations, but let's talk about the aggregation first. So one class belongs to a collection, but we have an object that can exist in more than one collection. So there's not direct ownership. You may be responsible for multiple containers or be a part of multiple containers. We'll come up with a couple of examples of this here momentarily. So no ownership is applied. You'll have a hollow diamond on the contains side. And composition is exactly kind of the opposite of that. So again, there's ownership implied now. A member can only have one associated container. And you can think of a strong as a relationship as a way of talking about this. So they're both diamonds. Aggregation is hollow, composition is filled. I find it to be easiest to say, does the container own the containee? So as an example, which one of these is aggregation? Which one of these is composition?
The left one is composition. Oh, no, the right one is.
Back to 212 for those who are in 212. Maybe it's a good thing we're going over this again. So which one is owned? A car owns its wheels. You can take off tires, but wheels are actually attached to the car. And you have to dismantle the entire car. And one might even argue it's not the same car if you replaced all of that in the car. So yeah, we're gonna go with left side is composition, right side is aggregation. Project with consultants, you can have a consultant that can be on multiple projects at the same time. There's no ownership directly applied, like this is the consultant for this project, this is the project for this consultant. Does that make sense? Another example, again, I haven't changed this. CSCD 350 and student and cat and classroom. Obviously, this is the building that we are in, not meow. The building we're in right now, there we go, we did it. Yeah. So where is their ownership implied? Does this class own all of you? Debatable still, we'll see. Does this building own its classrooms?
Yes.
Yes, the building owns the classroom, right? This classroom doesn't belong to any other building, and it could not belong to another building. To rip out this classroom and move it to another building would destroy the concept of this building.
You replace every part of the classroom with the original classroom.
We're not going to. We're not going this was
Existential computer science.
this first was the Perseus' ship.
You want to talk more about this? Take compilers. I do a lot of this abstract thinking in compilers.
Already did 212 ethics. I don't need.
So yeah, this is the composition on the right this time, and the way to think of this is a student can be taking multiple classes at the same time. So there's no ownership implied of a particular class. You don't take one and only one class. You can be a student in multiple classes at the same time. To give you a code example, because I find this to be super relevant, especially for those who haven't seen this before. This is in Java, how you might be able to distinguish between composition on the left and aggregation on the right. according to those definitions, especially for those who did not take 212 from me, how can you identify why is this composition, why is this aggregation? How does that difference make sense and appear in the code?
Remind me what those words mean again.
So composition kind of has ownership implied. And you can't distinguish between, so now it's got car and engine. So the car owns its engine in composition, and the car does not own its engine in aggregation.
So I would say, because that is being created with like a method in car, and that is just setting an engine and it's a void, so there's no like output.
Yeah, we're making the engine in the constructor, so there's no way to separate these things. At construction, they're paired, and there's no way to break them apart. In order to get rid of this engine, you have to destruct the car. Whereas here, we're passing in an already made engine, and we're associating that engine with the car. You can even think of it as an aggregation. We're aggregating the engine into the car. We're taking an already existing object and we're saying, all right, you are now aggregated together. You're two things that work separately, but now you're considered to be one thing. We have now set this field that used to be nothing. This used to be a big hole in the car. We've set it with this engine that we paired in this. It's not the constructor, it's a set engine method and not the actual constructor of the car. Note now that when we want to move the car, every car has to have an engine. Right? You can't have a car without an engine, because to make a car, you make an engine. So there's no check that needs to be done of, does this car have an engine? Of course it has an engine. Every car has an engine. So engine, do your thing. With aggregation, it's possible to have a car without an engine. This engine could be null. It could not have been set yet. If it hasn't been set, then we don't want to get a null pointer exception when we try to tell some engine that is null to do something that it doesn't know how to do. All right, composition and aggregation, I just say that in general, it's not super important for the scope of the class itself, but it's very useful in general because these two are very frequently confused. And so it is good to know the difference between composition and aggregation, because these are two of the types that are going to be part of our project this quarter, so you will need to know the distinctions between them. Another one that will be part of our project is generalization. This is an inheritance relationship. It's kind of a general term for an inheritance relationship. So here we have the superclass, here we have the subclasses. You have a triangle of the superclass, you have arrows pointing to the generalization. Here's another example. This is a multi-layer. Here we have the superclass with two subclasses, but one of those subclasses is a superclass for another class. So you can have an arbitrary generalization hierarchy. Questions on generalization of the term? Again, it's really just important to know the term, the symbol. That's all we're going to need for the scope of this project, but it's useful for being able to do diagram related work. Last one, realization, implementation of functionality that is defined in another class, which is very interesting to think about. If one place has the instructions and one place does the work, then we need some kind of realization that says we're going to do what is described over here. So an example of this is a printer setup and the actual printer. So the printer setup might be just a sequence of instructions for how to set up a particular printer. So we have this dashed line followed by an open triangle that says, if we want to set up this printer, follow these instructions. This will make this class usable. So here's some more examples. Here's some more examples. We can kind of see now that this might be more similar to what your project might look like. I'm basically done with this. I'm not gonna do this too much longer. I don't feel like it's necessary to go into too much more detail about the other types. But you can now see how we have class diagrams, names, fields, those fields have types. We have methods, those methods take parameters, those parameters have names and types. Each one of these have some associated relationships. They may have none, but you can see that we have relationships, we have quantities, and we have relationship types. So a project is composed of multiple activities. One or more activities. So that is how that would be read. Questions on just kind of that process? It really helps you to be able to visualize the details of a large project. So far in your classes, most of you have probably mostly done something that you can handle by yourself that is smaller in scope. 2 or 3 classes at most, unless you took 212 and wrote my lovely 20-ish class airplane project. Brings back nightmares, I can see it in your eyes. But if you haven't done something to that scope and scale, then being able to visualize something at that scope and scale requires you to really abstract from code, from an IDE. And looking at diagrams like this can really help with that. All right, any questions on anything that we covered with regards to what a UML diagram is, the purpose of a UML diagram, kind of the components, the different relationship types? If we have time later in the quarter, we may come back to more of this just as an interesting aside, but I think there is more important stuff that will be more relevant to sprint 1 to cover. So that's where I'm going to transition if people don't have any questions or concerns. All right, code reviews. These are extremely important, and I will be requiring them as soon as I finish with this slide deck. This may be something like the very start of lab tomorrow if I don't finish this today, trying to finish it today. So obviously, it's difficult to assure the quality of a software product. We know this because no testing is really enough, right? You can write as many unit tests as you want and you're still never sure. You don't want to go through the rigor of mathematically proving that your program works. We'll talk about how that works in more detail later in the quarter, but it's a huge pain to try to even verify a small product, let alone a small piece of code, let alone your entire product. So what kinds of things can we try to assure? If we are building the right system, we can use some kind of word I'm looking for. I hate it when I do this. Specification document of some kind to make sure that we're building the right product. Are we building the system right? Is the system architecture going to be able to handle this as part of the design part? The presence or absence of good or bad properties. What are those properties? Have we communicated with the client enough to be able to know that? Are we trying to identify any errors in an existing product? Have we written enough unit tests to be able to say that with some amount of certainty? Confidence, how confident are we in the absence of errors? Are there still bugs that we don't know about? How vital are those bugs going to be that we don't know about? Is it robust, safe, secure, available, reliable? All of these kinds of questions that we can ask. Is it understandable? Is it documented well so that another programmer can hop into the project? Is it usable? Is it modifiable? Is it cost effective? Why do we care? There are, of course, business reasons. The people we're making this for want to make money off of it or use it to increase efficiency. Are they spending their money on the best possible company to be able to produce this product? So is it cost effective? Does it use more power than it needs to? Is it gonna increase the company's energy bill after deployment? A bunch of questions that we can ask. Legal reasons, ethical reasons, social reasons, so tons of reasons why we might care to assure a particular product. How do we know that we have a product? How can we say, I assure you of this certain level of reliability to any of these questions above? So we're diving into what power do we have as developers to improve this. Challenges of creating large-scale projects. Maintainable code is very important. So for those of you, I mean, everyone in here is taking design patterns, but I especially tried to emphasize this when I taught it, is that the purpose of design patterns is to make future modifications to your code as easy as possible. You don't need to make large sweeping changes to your code that all create a bunch of dependencies and a bunch of potential issues that need to all be resolved before you finally have a working system again after making one small change. Think of it like a very large spread of dominoes. One small change leads to 3 changes, leads to 7 changes, leads to 13 changes, leads to 21 changes, leads to the rest of your life. Code that isn't unnecessarily verbose or doesn't have multiple different pieces of code for handling the same thing. Is the code readable? If we needed to go make changes, how easy would it be to interface with that code? Does the code have issues? Is it bug-free? Did we find all of the bugs and squash all of the bugs in our first iteration of development, or are there still existing bugs? It's worth talking about different kinds of testing. So you all are pretty familiar with unit testing, hopefully. We'll go into another unit on more in-depth unit testing in a bit. But functional testing and integration testing both have higher levels of defect detection rates, but unit testing is the worst kind of test. You only catch about 1 in 4 issues by writing a unit test for it. It's better to find 1 in 4 than 0, but that leaves a lot of potential bugs in the system that we don't have, we can't handle, or we need some other way to be able to handle. So this is what a code review is for. A code review is not code that you write. A code review is handing off your code to another developer and having them look over the code that you have written. So think of it like releasing a game to the public and getting a review written about that. You're going to release this to one and only one other developer, and they're going to review your code. In order for your code to be a part of your project, it needs to pass this code review. Now, anyone can do this code review, but you want to be looking for the kinds of things that are difficult to catch yourself. So a good analogy for this would be someone writing an article. The effectiveness of an automatic spell check, grammar check versus the effectiveness of an author editing their own article, or the effectiveness of an author hiring another author to also edit their edited work. The more layers of this you have, the fewer bugs are gonna sneak through into the final product. So spell check and grammar check is kind of the same as an IDE saying, hey, this is a syntax error, or hey, there's a semantic error here. Here's an auto-suggested fix for that. That auto-suggested fix may be what you intended and it may not be. You don't want to just accept that without verifying this is exactly what I wanted in my code, just like with a spell check or grammar check. Sometimes I still get grammar checks on Outlook that are not right. So using your own knowledge to verify that, but it's not particularly effective. If you edit your own article, how effective is it? You only know what you know. You don't know what other people know that you don't know. You don't know that you don't know it. Otherwise, you would know it. If you have other people looking at your writing, after you look at your own writing, you're gonna catch as much as you can. So mechanics, this can be done in person, it can be done offline, doesn't really matter. Early, I recommend doing this as part of hop in a Discord call together. One of you shares the code and you go over that review yourself in person. Remotely, but together. The reviewer is going to be looking for suggestions. What can we do at the logical level, at the structural level? You're going to try to have some kind of quality standard to your code. Does it adhere to the same, like, are we saying that all variables are camel cased or underscored? If it doesn't interface well, then you may be reading eventually some class where variables change. You have different variables in different formats, depending on who wrote that particular piece of code. That leads to a less readable piece of code. So you're going to want particular standards that you're going to hold yourself to and the rest of your group to. Note that this feedback is not judgment. The purpose of it is to refactor the code, to make the code better, make it easier to work with, easier to change later if needed. The whole purpose is to produce the best quality that you can for your code to the best of your ability. Throw away the ownership of that code. You're not making a mistake. You're not doing this yourself. You're not responsible for it. It's just everything for the greater good, the quality of the product. If the reviewer sends it back and says, these changes need to be made. These are not changes that you make in person in real time. You identify what needs to be changed. The reviewer will reject the code. The developer will go back, make the associated changes, bring it back to that same reviewer who says, does this now pass the standard that we all agreed on? Only once the reviewer accepts the code can it be pushed to your repo. So that way your repository has a second pair of eyes on every piece of code that has ever been contributed to it. When do we do a code review? We want to make sure that some functionality is done, something that is complete and testable. Think about when you would want to merge a feature into the develop branch. That's when you want to do a code review. When you want to take something that you've personally been working on and put it into what the group has been working on, then the group needs to agree that it adheres to their quality. So why do we do it? More than one person for every piece of code. This helps with the bus factor, right? If something happens, then at least someone has code reviewed every piece of the code that is there, that is not the one person who developed it. So it's a better understanding of all of the code that's part of your project. This also forces people, knowing that you're going to be doing a code review eventually, to hold yourself to a higher quality standard. You have to be able to defend what you have done and why you have done it. If the reviewer says, why did you do it this way? You need to understand why it happened. If you're pulling code off of ChatGPT and you don't understand why, then you're not going to understand why it breaks. You're not going to be able to debug it. That's going to be a big problem when something doesn't go right. Someone points back to your code and says, why doesn't this work? You need to be able to answer that question. This gives a nice hands-on learning experience. If you're taking this class and the rest of your team has another year worth of classes, that's not a problem, but it gives you an extra ability to learn from them, because you can watch their process. You can watch them look at your code and find some ways that you can improve it. That is a learning experience. That is what we are here for. And it also forces people to be involved in different parts of the system that they might not have developed from scratch themselves. So note that accountability is now at both the author and reviewer's level once it's part of the project. We can't just go back to the developer at that point and say, you produced this code, you're responsible for it. If it was committed to the repository, then both the author and the reviewer are responsible for that code. So take that very seriously if you're the reviewer. You're not trying to make friends with the author, you're trying to prevent future issues. Prevent future bugs, make it as easy as possible to work with the product. I guess we'll come back to this. I think maybe what I want to do is go to the very end of this and talk about kind of an example. Looks something like this. This would be how you want to do this. Dividing the checks into standards, comments, logic, error handling, and decisions. And allowing you to comment directly into the code in the commit, which you can do in GitHub. You can just make sure that you're doing some kind of experience, you have some kind of document for doing a code review. Looks kind of like this. And now that we've gone over it, make sure that you are code reviewing. Before you merge anything into this, make sure that you go through that. On GitHub, you can open a pull request. This is exactly how this is going to be done. When you want to merge a branch, do it through a pull request. And that will force someone else who is a collaborator to take on that role of the reviewer. So pull request, that's what that is. Whenever you're merging branches, a feature branch into that, open a pull request. We'll talk about this a little bit more at the startup lab, but I want as much of that time as possible to be yours. So I'll see you tomorrow for that. I'll be in my office for a bit. If you have any questions or concerns.
Yeah.